Welcome to Lucid Mind Chemistry channel. In this video, I have put together some questions related to the topic enthalpy changes. For links to other topics and question timestamps, please visit video description. Question 7. An experiment was performed to determine the enthalpy of combustion of ethanol. We have thermometer, test tube, water, spirit burner and ethanol that is combusted. The data collected are shown. We have mass of water, mass of ethanol, temperature rise, molar mass of ethanol and specific heat capacity of water whose value is given. Which expression can be used to calculate the enthalpy of combustion of ethanol in kilojoules per mole? For finding out enthalpy change, we can use the formula delta H is equal to minus mc delta T, where delta H is the enthalpy change, m is the mass of water which is W grams, C is the specific heat capacity of water which is given as 4.2 joules per Kelvin per grams. Delta T is the change in temperature which is given as Y. Now this is given in degree centigrade. There would be no effect if it was in Kelvin because temperature rise is always the same whether it is degree centigrade or Kelvin. So we can write Y Kelvin. Putting values in this equation, enthalpy change of combustion will be minus m. Instead of m we are going to write W. Instead of C we are going to write 4.2 joules per Kelvin per grams. W was given in grams. Change in temperature is going to be Kelvin, so we can write Y Kelvin. Now we can cut grams with per grams, per Kelvin with Kelvin, so we have minus W into 4.2 joules into Y. Now this shows the energy that is released by burning X grams of ethanol. But they have asked to find it in kilojoules per mole. Let's first convert this equation into kilojoules. We have joules, so we can divide it by 1000 to make it kilojoules. So delta H will be minus W into 4.2 into Y divided by 1000 kilojoules. So this shows enthalpy change of combustion in kilojoules for X grams of ethanol. Now we have to find it for moles, not for grams. So let's convert this grams into moles. The formula is number of moles is equal to mass in grams divided by molecular mass. So mass in grams is X, molecular mass is Z. So number of moles is X divided by Z. Now we can change this enthalpy change into moles by dividing with X by Z. So we can write delta H equals minus W 4.2 Y divided by 1000 divided by number of moles which is X by Z. So now final equation will be delta H equals minus W 4.2 Y into Z divided by 1000 into X. This is the enthalpy change of combustion of ethanol in kilojoules per mole. Similar equation is given in A, so therefore A is correct answer. Question 4. Solid sulfur consists of S8 molecules. Which equation represents the standard enthalpy of atomization of sulfur? Now, according to the definition, we know that the standard enthalpy change of atomization is the enthalpy change when 1 mole of gaseous atoms is formed. So let's find out in which equation are 1 moles of gaseous atoms being formed. So this is 1 mole, this is 1 mole, this is 8 number of moles, this is also 8 number of moles. Second part of the definition says that from its element under standard conditions. So we know that in standard conditions, sulfur is present in solid form as compared to the gaseous form. So therefore answer is part A. Question 7. Which equation correctly represents the standard enthalpy change of atomization of the given element? Now you have to remember the definition of enthalpy change of atomization. In this, what happens that 1 mole of gaseous atoms are formed from elements in standard states. Now we can see in A we have 1 mole of product, in B we have 1 mole of product, in C we have 2 moles, so therefore C is incorrect. In D we have 1 mole of ionic product. In A we have iodine, which is in gaseous state. Now iodine is normally in solid state, it is not gaseous, so A is incorrect. In B we have sodium solid, which converts into sodium atom, so this could be correct. In D we can see sodium atom is converted into sodium ion, so therefore this is ionization energy. So D is also incorrect. The correct option is B. Question 33. Gaseous sodium ions can be formed from sodium atoms. Which quantities are required to calculate the enthalpy change of formation of sodium ion? Now we know that we can find the enthalpy of formation by using Hess's law. We have sodium solid, it converts into sodium ion. Now sodium solid can be first converted into gaseous sodium atom, and then we have first ionization energy and we can convert sodium atom to sodium ion. So in this step from solid to gaseous we have enthalpy of atomization involved, while in this step from sodium gaseous to sodium ion we have first ionization energy involved. So by using Hess's law we can actually find this enthalpy change of formation. So the options are 1. First ionization energy of sodium, yes we need this one. Second is enthalpy change of atomization of sodium, we also need this one. Third is the enthalpy change of formation of sodium. Now this is not needed. So the correct answer is B. Question 8. Which equation represents the standard enthalpy change of formation of water? Standard enthalpy change of formation is when 1 mole of product is formed from its elements in standard state. As it is standard enthalpy change, so the conditions must be standard. Let's find out whether we have 1 mole of product or not. In first one we have 1 mole of water, in second one we have 1 mole of water, in third and fourth we have 2 moles of water formed, so these are incorrect. Now the components of equation should be in their standard states under standard conditions. Now we know that water is in liquid state under normal conditions, it is not gas, so B should be correct. The answer is therefore B. Question number 4. The following data are needed for this question. Now, two different types of enthalpies are given. One is of sodium bicarbonate. Second is of sodium carbonate. Both are reacting with HCl. On heating, sodium hydrogen carbonate decomposes as shown. What is the enthalpy change for this decomposition? So we have to find the enthalpy change of decomposition. As three different reactions are given, so we can use Hess's law. So writing the main equation, we have 2NaHCO3 solid gives sodium carbonate solid along with water liquid and carbon dioxide as gas. Now NaHCO3 also reacts with HCl and forms HCl and forms sodium chloride along with water and carbon dioxide. Similarly, sodium carbonate also reacts with HCl and forms the same product. We just have to balance sodium. Now it is balanced. Now let's see, according to Hess's law, which is one-step process and which is two-step process. If this is the reactant, and this is the final product, so this is going to be A, and two steps are involved here, so this is going to be B and C. So according to Hess's law, A is equal to B plus C. Now we have to find the enthalpy changes in A, B and C. 2 NaHCO3 are giving 2 NaCl and water and carbon dioxide. So 2 moles of NaHCO3 are involved. So taking value from the first equation, we have sodium carbonate with HCl and the enthalpy change is minus 38.97. So as 2 moles are involved, it will be 2 into minus 38.97. It comes to be minus 77.94. B step is something that we have to find out. C is also given in the question. Sodium carbonate plus 2 HCl gives minus 96.59. So C is minus 9659. Just putting the values that we have. Minus 77.94 is equal to B plus minus 96.59. So B is equal to minus 77.94 plus 96.59, and therefore it is 18.65 kilojoules per mole. So the answer is positive, so it is C. Question number 33. A reaction between carbon and oxygen is shown. This is the chemical reaction. Carbon and oxygen, they are forming carbon monoxide gas. How can the standard enthalpy change of this reaction can be described correctly? Now, one says standard enthalpy change of formation. Now, what is enthalpy change of formation? It is the enthalpy change when 1 mole of a compound is formed from its element in standard state under standard conditions. So yeah, this is fulfilling the equation, because one mole of carbon monoxide is being formed from carbon and oxygen, and both are in their elemental states. So yeah, this could be the enthalpy change of formation. Second is the enthalpy change of combustion. The enthalpy change of combustion is basically when 1 mole of a substance is burnt in excess oxygen. Now in this equation you can see that oxygen is not in excess, but actually only 0.5 moles of oxygen gas are given. That's why it is not properly combusted and carbon monoxide is formed instead of carbon dioxide. So it is not enthalpy change of combustion. Third is the enthalpy change of atomization. In enthalpy change of atomization, 1 mole of gaseous atoms is formed from its elements under standard conditions. So in this equation there are no atoms, but actually carbon monoxide is formed, which is a molecule. So this is also wrong. We just have one option, which is 1. So the answer is D. Question 8. Nitrogen and oxygen can react together to form nitrogen monoxide NO. The reaction is endothermic in nature. What is the bond energy for the bond between the atoms in NO? This enthalpy change represents the overall enthalpy change for the reaction. So we can write delta HR, which is equal to the energy involved in bond breaking and energy involved in bond forming. So we can represent bond breaking by delta H1, bond forming by delta H2. So delta H1 is the energy required to break these bonds, and del H2 is the energy released from forming this bond. Now from data booklet we can find the values. For breaking N triple bond N, the energy required is 944 kilojoules per mole. For breaking double bond in oxygen we have 496 kilojoules per mole energy. So combining these two we can find delta H1. As this is bond breaking, so it is always endothermic and the sign is positive. So 496 plus 944, this is for delta H1. The bond formation in NO, the energy can be represented by X, as there are 2 moles, so we can write 2X. Now 2X is the energy released, and that is in bond formation. Now we know that energy released is always exothermic in nature, so for delta H2 we can write negative 2X. This is because the bond is being formed and the energy will be released. Total energy is given, which is overall energy of the reaction. It is 180. Now we can rearrange the equation. X equals 630 kilojoules per mole. This represents the bond energy between nitrogen and oxygen. Answer is therefore A. Question number 5. Two reactions are shown. Hydrogen gas converts into hydrogen atoms. Carbon monoxide converts into carbon dioxide gas. If molar amounts are used, how can the two energy changes associated with these reactions be described? So let's see what are the energy changes associated with these equations. A. Enthalpy change of atomization and enthalpy change of combustion. Atomization is actually when 1 mole of atoms is formed from the elements in the standard state. So in this equation actually 2 moles of hydrogen atoms are being formed, so this is not the standard enthalpy of atomization. And enthalpy of combustion is when some substance is burnt in excess of oxygen to form the product. So in this equation carbon monoxide is being combusted in the presence of oxygen to give carbon dioxide. So yes, it is enthalpy of combustion. Part B, enthalpy of atomization, again this is wrong, and enthalpy of formation. Enthalpy of formation is actually when 1 mole of a compound is formed from the elements in their standard states. In this equation carbon monoxide is not an element, there should be actually carbon in the solid state, then this was correct. So this is also wrong. C, bond energy and enthalpy of combustion. Bond energy is something when a covalent bond is broken into its atoms. So yes, hydrogen gas is being converted into hydrogen atoms, so actually hydrogen bonds is being broken and it forms 2 hydrogen atoms. Enthalpy of combustion, it is correct as we already studied, so it could be part C. Part D says bond energy is correct for hydrogen, and enthalpy of formation. Now this is not enthalpy of formation because the elements are not in their standard states. So the only option is part C, and that is the answer.
Question number 6. Which pair of standard enthalpy changes are numerically equal? A. Atomization of CH4 gas and formation of CH4 gas. Atomization means that the compound is changed back into respective atoms. We have 1 atom of carbon and 4 atoms of hydrogen, and both are in gaseous state. While formation of CH4 means that the CH4 gas is being formed from its elements in their standard states. Now element is carbon and hydrogen exists as H2. So carbon will be solid and hydrogen will be gas. Now we can see that in atomization hydrogen is in atomic form, while in formation hydrogen is in molecular form. Again carbon is in gaseous atomic form in atomization, while it is in solid form in formation. So therefore both are not equal. This is incorrect. B. Combustion of methanol liquid and combustion of graphite plus 2 into combustion of hydrogen gas. Let's first write the equation for combustion of methanol. We have CH3OH in liquid form. It combusts in the presence of oxygen to form carbon dioxide and water. We can balance this equation by writing 2 with water and 3 by 2 with oxygen. Combustion of graphite will be carbon in the form of graphite plus oxygen, it will form CO2. And combustion of hydrogen will be H2 gas plus oxygen, it forms H2O multiplied by 2. Now we can see that we have same products in both reactions. We have 1 mole of carbon dioxide and 2 mole of water. Again we have 1 mole of carbon dioxide and 2 moles of water. But we can see that the reactants are different. One is methanol, second is carbon and hydrogen. So therefore as the reactants are different, so the enthalpy change will also be different. So B is incorrect. C. Combustion of graphite and formation of carbon dioxide. Now we can write the equation for combustion of graphite. Carbon solid combusts in the presence of oxygen to form CO2 gas. Now we can also write the equation for formation of carbon dioxide. So carbon dioxide is formed from its element. One of the element is carbon and the other element is oxygen, and the standard state is that carbon is in solid form and oxygen is in gaseous form. Now we can see that the reactants and products are same and the number of moles are also same, so therefore they are numerically equal values. So C could be correct option. D. Neutralization of HCl with NaOH aqueous and formation of H2O. Neutralization of HCl and NaOH can be shown by this equation. We have HCl aqueous, sodium hydroxide aqueous. It forms sodium chloride along with water. Secondly, we can write the equation for formation of H2O liquid. So H2O liquid will require elements hydrogen and oxygen in their standard states. Now we can see that in both reactions same number of moles of water are being formed, but we have different reactants. For neutralization we have HCl, NaOH and sodium chloride is also formed, so therefore the values will be numerically different. So it is incorrect. The answer is therefore C.
Question 32. Which statements are correct? 1. Enthalpy of combustion of hydrogen is equal to enthalpy of formation of H2O. Now we can write the combustion of hydrogen. Hydrogen plus oxygen, it combines to form water. We can balance number of oxygen atoms by writing 1 by 2. Second is the enthalpy of formation of water. Now we know that in enthalpy of formation of water, 1 mole of water is formed from the elements in their standard states. So therefore the equation is same for enthalpy of combustion and enthalpy of formation of water. So 1 is correct. 2. Enthalpy of formation of hydrogen is equal to enthalpy of atomization of hydrogen. Now as H2 is already in molecular form and therefore the enthalpy of formation of H2 will be equal to 0. While the enthalpy of atomization of hydrogen means that hydrogen molecule converts into hydrogen atoms. So this will be endothermic in nature. Multiplying with negative, the value will become negative. So therefore still this is unequal to 0. So the enthalpy of formation of hydrogen is not equal to the enthalpy of atomization of hydrogen. So 2 is incorrect. Third is the enthalpy of solution of HCl. Now enthalpy of solution is the enthalpy change when 1 mole of HCl is dissolved in water to form infinitely dilute aqueous solution. Second is the enthalpy of hydration of H plus ion. So we can write H plus plus water. It is hydrated to form H plus aqueous. Now it moves from gaseous state to aqueous state. Second is the enthalpy of hydration of Cl negative. Again it is in gaseous state and hydration makes it aqueous. Now as hydrogen gas and Cl negative gas is in atomic form while HCl is in molecular form, so therefore enthalpy of solution of HCl is not equal to the enthalpy of hydration of H plus and enthalpy of hydration of Cl negative. 3 is therefore incorrect. The only correct option is 1, so therefore answer is D.
Question number 8. Which pair of enthalpy changes will always share the same sign? That is, both are always exothermic or both are always endothermic. A. Enthalpy change of atomization. Now what happens in atomization is that we break down a molecule into its atoms. For example, we have hydrogen. We can break hydrogen molecule into the atoms of hydrogen. So the breaking of bonds requires energy, so therefore enthalpy change of atomization is endothermic in nature. Enthalpy change of neutralization is when acid reacts with alkali to form salt and water, and this reaction is always exothermic. So A is incorrect. B. Enthalpy change of atomization, again this is endothermic. And enthalpy change of solution. Now what happens in solution, that a solute is dissolved in enough volume of solvent to make up a solution. Now the enthalpy of solution is dependent on the type of solute. So it could be either endothermic or exothermic in nature. C. Enthalpy change of combustion. In combustion, what happens that something burns in the presence of oxygen and it is exothermic in nature as energy is released. Enthalpy change of hydration is when gaseous ion converts into aqueous ion. Now we can see that the gaseous atomic ion has very high energy as compared to the aqueous ion, so the energy is released in enthalpy change of hydration. So it is also exothermic in nature, so C could be correct option. In D we have enthalpy change of solution, which is dependent on the type of solute, so it could be exo or endo. And enthalpy change of hydration, which is exothermic in nature. So in C we can see that the enthalpy changes are always the same, so therefore answer is C.
Question number 9. The equation for a chemical reaction is shown. All substances are in their standard states. Xenon hexafluoride reacts with water to form xenon trioxide and hydrogen fluoride. Which statement describes the standard enthalpy change of reaction for this reaction? So you have to remember that for standard enthalpy change of reaction, the number of moles are not specific for chemical reaction. There could be any ratio of number of moles as long as the equation is chemically balanced. So in this equation we can see that we have 1 mole of xenon hexafluoride which reacts with 3 moles of water to form 1 mole of xenon trioxide and 6 moles of HF. So we have 4 moles in total of the reactants and 7 moles of product. Let's move towards the options. A. The enthalpy change when a total of 1 mole of product is produced. In this reaction there is 7 moles of product being produced, so therefore this is incorrect. B. The enthalpy change when a total of 1 mole of reactants is reacted. As the number of moles are not specific, in this reaction there are 4 moles of the reactants being reacted, so this is also incorrect. The enthalpy change when 1 mole of water reacts. In this equation we can see 3 moles of water is being reacted, so this is also incorrect. D. The enthalpy change when 6 moles of hydrogen fluoride are produced. So in this chemical equation we can see that 6 moles of HF are being produced, so therefore this corresponds to this chemical equation. So the answer is D. Question 33. Which statements about enthalpy changes are correct? 1. The enthalpy change of atomization is always positive. This is true statement because atomization is the conversion of element or molecule into atoms and it requires energy in order to break the intermolecular bonds or forces. For example, carbon solid can be converted into carbon gas upon heating. So therefore the change is endothermic. Option 2. The enthalpy change when a carbon-carbon bond is broken is positive. Now this is also true because bond breaking is always endothermic. As it always requires energy to break a chemical bond. 3. The enthalpy change of neutralization of weak acid is always negative. Now neutralization is the reaction in which acid reacts with alkali to form salt and water. And whether the acid is weak or strong, the enthalpy change is always negative as the energy is released. As all three options are correct, so therefore answer is A. Question 33. For which enthalpy changes is the value of delta H always negative? Negative enthalpy change means exothermic chemical reaction as energy is released. First one is combustion. As we know that energy is always released in combustion, so this is exothermic reaction and delta H will be negative. Second is hydration. Now enthalpy of hydration is the energy released when attractions are set up between ions and water molecules. The ions can be positive or negative. So when forces of attraction are developed between ions and water molecules, what happens that energy is released. So it is also exothermic. Third is the enthalpy of solution. Now enthalpy of solution could be positive or could be negative. It depends on the type of salt that is dissolved in water. For example, if we have calcium chloride, the enthalpy of solution is negative 81.3 kilojoules per mole. So it is exothermic in nature. While if ammonium nitrate is dissolved in water, what happens that the enthalpy change is positive, so it is plus 25.7 kilojoules per mole. So it could be positive or negative, so therefore it is not always negative. As option 1 and 2 are correct, the answer is therefore B. Question number 8. Sodium burns in oxygen, giving out heat energy and forming the compound sodium oxide. The equation for this reaction is shown. 2 moles of sodium reacts with half moles of oxygen to form 1 mole of sodium oxide. Which statement about the reaction is correct? A. Enthalpy change for the reaction is equal to twice the bond energy of the sodium-oxygen bond. Now we can see that sodium is a metal and it is from group 1 of the periodic table, while oxygen is a non-metal of group 6. So the bond formed between sodium and oxygen is ionic bond. While here they have shown covalent bond. So therefore A is incorrect. B. Enthalpy change for the reaction is positive. As we can see in the reaction that the heat energy is given out, so it means that it is exothermic reaction. So for exothermic reaction, the enthalpy change is always negative. It is not positive, so B is also incorrect. C. The equation represents the standard enthalpy change of combustion of sodium. Now for combustion of sodium, the standard enthalpy change will be defined as when 1 mole of sodium is burnt in excess oxygen to form sodium oxide. As in this equation we can see that 2 moles of sodium are used, so therefore C is incorrect. Now part D, the equation represents the standard enthalpy change of formation of sodium oxide. Now this is a true statement because the enthalpy change of formation states that when 1 mole of product, which in this case is sodium oxide, is formed from the reactants in their standard states. So sodium is solid in standard state, oxygen is gas in standard state. So option D is correct. The answer is therefore D. Question 7. The enthalpy change of reaction 1 is minus 114 kilojoules per mole. This is reaction 1. We can see that alkali and acid, they react to form salt and water. By using this information, what is most likely value for the enthalpy change of reaction 2? In reaction 2, we can see that alkali and acid are reacting to form salt and water. So both reaction 1 and reaction 2 are neutralization reactions. In both reactions, we can see that 2 moles of water are being produced upon neutralization. As in NaOH, we have 2 hydroxide ions that combine with 2 H plus ions from sulfuric acid. So it forms 2 water molecules. Similarly, in barium hydroxide, we have two hydroxide ions that combine with H+. Now 2 moles of HCl are present, so therefore the number of moles of H+ will be 2, and it combines to form 2 moles of water. So the ionic equation is exactly similar in both, so therefore the energy change will also be same. Reaction 2 will also show negative 114 kilojoules per mole energy change. Question 33. For which reactions does the value of enthalpy change represent both a standard enthalpy change of combustion and a standard enthalpy change of formation? Now in standard enthalpy change of combustion, we can say that when 1 mole of substance is combusted in excess oxygen, to form products in standard states under standard conditions. In standard enthalpy change of formation, we can say that it is the enthalpy change when 1 mole of product is formed. From its elements in standard states under standard conditions. Now in given options, we can see that 1 mole of carbon dioxide is present, 2 moles of carbon monoxide is given, so it is incorrect. There must be 1 mole of substance and 1 mole of product. In 3, we have 1 mole of carbon dioxide present, so it could be correct. Now second thing is to look at the reactants. In 1, we have elements in their standard states. Carbon is in solid form, oxygen is in gaseous form, so it is enthalpy change of formation. And it is also enthalpy change of combustion because 1 mole of carbon is being combusted in excess oxygen to form product. So 1 is correct. In 3, we can see that carbon monoxide reacts with oxygen to form carbon dioxide. So as carbon monoxide is not an element, it must be an element for enthalpy change of formation. So therefore 3 is wrong. As only first option is correct, the answer is D. Question 1. Which statement about enthalpy changes is correct? Part A. Enthalpy changes of atomization are always negative. In atomization, element is converted into individual atoms, and this can happen only when energy is absorbed and intermolecular forces or bonds are overcome. Therefore, enthalpy changes of atomization is always positive as it is endothermic process. So A is incorrect. Part B. Enthalpy changes of combustion are always positive. This is also incorrect because whenever combustion takes place, heat energy is also released. It is always exothermic reaction. And enthalpy change should be negative. Part C. Enthalpy changes of formation are always positive. What happens in formation is that some compound is formed from its elements in their standard states, and whenever a compound is formed, it means the forces of attraction develop or the bonds develop. So whenever bonds are formed, the process is exothermic. So bond formation is always exothermic as energy is released. Part D. Enthalpy changes of neutralization are always negative. In neutralization, acid and alkali, they react together to form salt and water. The reaction produces heat, so therefore enthalpy changes of neutralization is always negative as it is exothermic reaction. Correct answer is therefore D. Thanks for watching. If this was useful, please do like, subscribe and share.